This next section, in section 9.7b, is another one of my favorites because it involves some shortcuts. Do you remember when we multiplied and FOILed a minus b times a plus b? When the binomials were exactly the same except one was a plus and one was a minus? When we did that, the middle terms dropped out and we were left with the first term squared minus the second term squared. Do you remember what these two were called to get the difference of two squares? They were called conjugates. Well, let's apply that idea. X squared minus 4. The first one's a perfect square, the second one's a perfect square with a minus in between. So the factored form is x minus 2 times x plus 2. Just as easy as that. Our next one, once again, they're both perfect squares with a minus in between. So it's x plus 1 times x minus 1. I specifically put them in a different order there because it really doesn't matter what they are. This is where it's really good to know your perfect squares. 169 is a perfect square, so that's x plus 13 and x minus 13. These are almost too easy. 64x squared minus 49. Those are both perfect squares as well. That's 8x on the front plus 7 and minus 7. Sometimes the back end will have a variable, and so long as the variable is squared, it still works. 10x times 10x is 100x squared. And negative 9y times positive 9y gets you the negative 81. So there's the conjugates for each of these problems as we move forward and go through these. Now let's look at the second part of this lesson. The second part of this lesson involves what happens if they're not perfect squares, but it still kind of looks like it. Well, a good thing to look for then is try to identify a GCF. Well, in this case, it's 10. So we take out that perfect square of that GCF as 10, and we go from there. What's it going to give us? Well, that's x minus 2 times x plus 2. Our next one, we're going to take out a 3 as a GCF, and that leaves us x squared minus 25. Once again, both of them are difference, and it's perfect squares, so it's x plus 5 and x minus 5. Moving down on our page, we take out our GCF, which is 4, leaving us x squared minus 100. And so as we take it out, we're going to have x minus 10 and x plus 10. Our last one, we have 11x as our GCF. When we take out that 11x, we're left with x squared minus 4. Here the GCF has an x in it. So we take that x out, and we have x plus 2 and x minus 2. The key idea for each of these problems is to identify that GCF correctly, which would leave you the difference of two squares. Speaking of squares, our square for today is 23. And 23 squared is 529. The numbers are starting to get up there, so keep practicing as you go through.